Now let's continue talking about net-to-net or site-to-site VPNs. NetServer supports two different protocols for site-to-site VPN. They are OpenVPN and IPsec. Depending on the situation, it may be better to use one or the other. Let's start with IPsec tunnels. IPsec is the de facto standard implemented on all network devices. It is almost the only choice when you want to connect NetServer with third-party devices. When using IPsec tunnels, both devices are equal. There is no server-client relationship. The configuration between firewalls need to match perfectly. Each device must be reachable, so you need a public IP address in both firewalls. And even if it's not mandatory, it's better than the red interface of the firewall is configured with a public IP address on it instead of a NAT. IPsec uses for all channels ports 500 UDP and 4500 UDP and the protocols AAH and ESP. Please forward this traffic from the router to NetServer if you are behind the NAT. The configuration of an IPsec tunnel is quite standard. If you are using TuneIt server, you don't need to configure advanced options because they will manage automatically. But if you are connecting the server to another brand, router, or firewall, you need to configure every specific parameter. Network parameters and IDs need to be inverted between the two devices, while phase 1 and phase 2 parameters need to be exactly the same to ensure everything works. There is not much more to say about IPsec, just to be very careful to fill in all fields correctly. And now we are going to talk about OpenVPN tunnels. There are many similarities between OpenVPN tunnels and OpenVPN Road Warrior. We developed these tunnels in order to provide a fully featured, easy to manage, and fast to create site-to-site VPN connection. First of all, we will have a look at the routing diagram, which is very similar to what we have already seen for Road Warrior tunnels. The only difference in this case is that NetServer itself is the client. So when a host from LAN B needs to talk with a host in the remote LAN A, it will send packets to its default gateway, that is, the NetServer B. Requests to LAN A will be managed by NetServer B and sent to NetServer A through the VPN tunnel. NetServer A will manage incoming packet from site B and will send them to the network A via its screen interface. At this point, the host in the network A will receive packets and will reply sending answers to its default gateway, that is NetServer A. Finally, NetServer A will route back answers to host B the same way. The OpenVPN tunnel uses a server-client logic. The server is the firewall that has a public IP address. It can also be behind the net and listens for connections from the client on a specific port. Every VPN tunnel must use a different port. The client this time is the firewall that contacts the server and tries to establish the connection. Once the connection is established, traffic will flow both ways. And it is very simple and fast to create a VPN tunnel. So we have just 3 steps. So first, create a new server. That server will help you to do it very easily with pre-filled values. Second, export the auto-generated file for the client. And third, import the file on the client. And that's all. You now have a working site-to-site tunnel. To create a server tunnel, simply click on Add Server Tunnel, and the system will show you an interface where almost everything is already filled. Public IP addresses are automatically obtained by the system, and there can be more than one if there are multiple ones configured. Local networks are already filled in with your green networks details. And the VPN network and port are automatically suggested by the system. You just need to assign a name, modify public IP addresses if you want, and specify remote networks. This type of tunnel natively supports automatic connection backup. So if the server has more than a one, the client will try to connect to the first public IP in the box. Then, if the first one is not available, it will try to connect to the second public IP and so on. For this reason, the order of public IP addresses or FQDN names is important because they will be contacted by the client in the same sequence as they appear in the box. Client configuration is straightforward. Just download the file created by the server and upload it to the client. We finish by going to explain which type of VPN to use depending on the case. So why use Openvpn? Openvpn is a modern protocol. It works very well through multiple nets and doesn't require a public IP address except for the server side. Openvpn natively supports connection backup and switches automatically to the next connection if the preceding is not working. Openvpn implementation allows us to create a connection quickly and easily. And why use IPsec? IPsec is still the de facto standard for site-to-site connection, and it is found in every network device like router or firewall. So if you need to establish a VPN with a device from another brand, IPsec is almost the only choice. So thank you for your attention.